the potential difference across live and neutral wire is 500 minus 0 means 500 volts. Now coming towards the next component, that is step-up transformer. So we have a step-up transformer. Now step-up transformer was the last thing that we have discussed, the last component. Step-up transformer is basically an electrical component which can transform, which can convert low voltage at large current to large voltage at low current. I'm repeating this, that step-up transformer is a transformer which can convert low voltage at large current to large voltage at low current. So that means that transformer is something which is used to increase the magnitude of voltage, but the combination, the product of voltage and current, it stays constant. If we have low voltage, then the current is definitely large, and if we have large voltage, then the current is going to be low. Now, at this point, some of you must be thinking that according to Ohm's law, what we have studied is current and potential difference, they are directly proportional. So what sort of a relationship is this, where we are saying that increasing the current will decrease, or increasing the potential difference will actually decrease the current. So normally what we used to say according to Ohm's law, that increasing potential difference will also increase current. But in this case, we are actually discussing the combination. Now, you need to understand that why I'm saying this. First of all, I'm repeating again. First of all, when we have discussed Ohm's law, we used to say that increasing the potential difference across a component will increase the current flowing through that component. Now, this is something very important. Potential difference across a component. We are talking about one component. कि अगर हम उसके across potential difference को increase करते हैं, तो उसमें से flow करने वाला current जो है, वो भी increase हो जाता है. और अगर हम एक component के across potential difference को decrease करते हैं, तो उसके अंदर से pass करने वाला current भी decrease हो जाता है. Are you getting my point? Now at this point, we are talking about one component. In case of transformer, there are two coils. I'm just showing you the working of transformer now today. Now I'm going to make you transformer. Okay. Okay, Vijay, so this is actually a transformer. They are basically sheets of soft iron which are separated by an insulating medium. अब आपको मैं यहाँ पर इस तरीके से ये दिखा सकता we have these sheets. The thing I'm showing in between, it's basically ये basically हमारे पास dielectric medium है. Insulating medium, simple words, maybe we can say that this is insulating medium. So this is basically insulating medium. The same way this insulating medium आपको यहाँ से भी नजर आ सकता है. Okay, so now we have soft iron sheets. These soft iron sheets are separated by this soft iron sheet is separated by dielectric medium. As you can see it from here.
सर ये पहला वाला ट्रांसफॉर्मर है ना?
जी बेटे,
पहला वाला ट्रांसफॉर्मर है ना?
जो बेटे मैंने आपको सिंबल दिखाया था ना,
जी सर.
मैं आपको पिछली डायग्राम में जो सिंबल दिखा रहा था वो इस डायग्राम में एक्चुअल ट्रांसफार्मर बना के शो करेगा. That how actually transformer looks.
इस डायग्राम में दो ट्रांसफॉर्मर्स थे ना, मैं पूछ रहा हूँ कौन से नंबर वाला, फर्स्ट के सेकंड?
बेटे एक ही है, दो किधर है? अच्छा
वो
मतलब वो जो पिछले वाली ड्राइंग थी उसमें दो ट्रांसफार्मर्स थे.
जी सर.
It's a general structure of transformer, general design of transformer. So we are not concerned that it's the first one or the second one, both can be. अभी which part will decide that it's a first or second transformer वो मैं अभी आपको
इसका
मुंह पे लिखा पेड़ू.
बेटे can you please excuse me please. Okay, now I'm showing you this part. This is a coil of transformer. अच्छा बेटे, अब ट्रांसफॉर्मर को which part will decide that this is a step up or step down transformer? It's a number of coil on the side where we have supplied the current to the number of coil on the side where current is induced. Now, what is an induced current? This is for you, the term that you are hearing for the first time. So I'll just give you an idea of what is an induced current. But right now, you just need to understand that how this transformer actually works. Now, the way I'm going to make it over here, it becomes the transformer, which is a step-up transformer. Now we can say, now you have to identify from which part I'm saying that it is a step-up transformer. Just try to look at the difference between the two sides of the coil. Once I'll complete this drawing. Okay, now Tell me what's the difference between the first side and the second side of the coil?
Tons of coil.
Yes, Nate, repeat.
Tons of coil.
Number of turns, very good. The number of turns are different. The number of turns in the primary coil are less than the number of turns in the secondary coil. Now, what is a primary coil and what is a secondary coil? Let's find it out that. But before that, I'm going to label a few terms over here so that you'll get to remember this part. Now, this side is basically the primary coil. This is the primary coil. This side is called the secondary coil. Okay, now this is soft iron sheet. This is an insulating medium. Take it, and that's it. Now I'm just going to write soft iron sheets and insulating medium. Okay. Over here in this part of the coil, which I made on this side, with alternating current, and on this side, we are getting current. So this is basically an ammeter. Alternating current sign and ammeter with it. Okay. Now I'm going to write this whole thing कि इसमें काम कैसे हो रहा है. देखिए, transformer is basically nothing else than the sheets of soft iron. These sheets of soft iron are piled up together. That means that they are stacked together one on another. It's just like that. I'll show you these papers. Now, for you can see that these are the printable papers, A4 size papers. This is one sheet of a paper. You can see it in the camera. And this is another sheet of a paper. Now what I'll do, I'll start placing sheets over another sheet and sheets over another sheets. Now you can see that you can get a whole pile of a paper like this in this formation. So transformer is basically nothing else than these sheets, which are individual sheets, and they are stacked together. They are piled on each other. And in between these sheets, like for example, this is the sheet, this. In between these sheets, I have to separate them with a special coating which is an insulating medium. That means that it's an insulator, electrical insulator. It does not allow electricity to pass through it. And at the same time, when we are saying that it's an insulator, at the same time, it allows electric field and magnetic field to pass through it. So particularly, it's a medium which insulates electrically. It don't allow electrical current to pass through it, and at the same time, it allows magnetic field to pass through it. For example, wax. So these sheets are separated by wax, just an example, and there are large number of sheets which are placed over here. Then we cut out a hole, a square hole inside this, in these sheets, in the middle of these sheets, and then we place a coil, as I have shown you over here. Now, this will form a transformer. Remember, that's an important part of transformer is that electrical power supplied to primary coil is always equal to electrical power supplied by secondary coil. Now, this is a very important part, and this is the part which actually defines that why the combination of potential difference and current, they are changing according to the law of conservation, principle of conservation of energy. Energy can neither be created nor be destroyed. That means that we can neither produce energy nor we can destroy it. What we can do, we can just convert it. And if I'll talk about potential difference, then potential difference is basically electrical energy. Because how we define potential difference? Work done per unit charge. So when I'm talking about work done per unit charge, it means that I'm talking about energy, because work can only be done if we have energy. So that means that potential difference is work done over charge, it's electrical energy over charge. So the more the work we are doing, the more the electrical energy is converted to other forms of energy. Now, when I say that the potential difference in the primary coil is less than the potential difference in the secondary coil, in one way, I'm just indicating that I'm creating energy. Now, a very important thing, potential difference, I've just told you it's electrical energy to do work in order to drive 1 coulomb charge. So when I say that potential difference is increasing, I'm talking about step-up transformer. It can increase the potential difference, the potential from low voltage, as I've told you, in the primary coil to the high voltage in the secondary coil. So in other words, I'm saying that I'm creating energy, I'm increasing energy, it can't be possible. So we have to obey the principle of conservation of energy. We cannot create energy. Now, how this is going to ensure that we are not talking about in creation of energy. This is ensured when we say that power in the primary coil is equal to power in the secondary coil. For that, I'm going to introduce to you a formula, and then I'll come back to this point. A few formulae. Number one. I'm just writing over here. Important formula. Okay, as we have just studied that power, work done, potential difference is equal to work done over charge. And we can write also as potential difference is energy over charge. So I'm talking about electrical energy. Now, so as per that, can I write V is equal to QV? So I think I can write E is equal to QV. Now, in the next step, where